Good morning, students. Today I am going to deliver you a lecture on the wave propagation. Now you all know that the basic application of antenna is wave propagation. Why we need to install the antenna, whether they are transmitting or receiving antennas, we need to have the wave to propagate through them. Now we will lead to this lecture to a very useful information through a free space equation. Free space equation or the free space equation was discovered by an eminent scientist in order to deliver the basics of the wave propagation, how the wave is being propagated through the transmitting and the receiving antenna. Through this equation, we will be going to study that how the effects of various antennas, whether they are isotropic or the directive antennas, affect the gain of the antennas and the wave that is being propagated to those antennas. Okay class, let us start with this free space equation now. Now the free space equation or the free space equation deals with the main transmitting antennas which are being used for the transmitting and reception of the signals. If we talk about the isotropic antennas which are capable of transmitting the signal in all the directions equally. That means the power that is being radiated by these isotropic antennas is transmitted equally in all the directions, and they have comparatively less signal strength towards one particular direction. So the power density for the isotropic antenna is given by the power transmitted upon the surface area of a sphere. That means that is a transmitted power which is being transmitted by this isotropic source which is capable of transmitting the radiations in all the directions equally. That is, power density is equal to transmitted power. Pt is your transmitted power which is being transmitted by the transmitter, and 4 pi r square is the area of a sphere. Now as we all know that the capability of the isotropic antenna is capable of transmitting the radiations in all the directions, so that is why we have considered the area of a sphere over here. So if we talk about a directive antenna now, this is our equation number A. If we talk about the directive antenna means which is capable of transmitting the radiations only in the one particular direction. That means the signal strength is diverted only in one direction. So that in those antennas are determined, or they are expressed by the directive antennas. So if we take the power density of these directive antennas, then these power density of these directive antennas will be given by the power density of directive antenna is equal to transmitted power upon area of a sphere with a gain factor which is being introduced over here. Now this gain factor is only because of this directive antenna. As we all know that directive antenna have the highest directivity. The directivity of these directive antenna is very high. So that is why the gain factor is being introduced by using this directive antennas. Now that was all about the directivity of the antennas, whether they are isotropic or they are directive antennas. Now if we talk about the wave propagation, when using any of these antennas, if the wave is being propagated out of any of the modes, then attenuation factor is also being introduced in this wave propagation. Antenna, we have the attenuation which is being introduced in this antenna propagation. Antenna propagation reduces the attenuation factor which is given by the factor alpha. And this is introduced, whether we are using factor which is introduced is alpha, Alpha is the attenuation which is introduced, either we are using the isotropic antenna or we are using the directive antenna. Any of these antennas introduces a factor attenuation alpha, because alpha attenuation factor is introduced in the atmosphere when the wave is being propagated through any medium. Through any medium the wave is propagated, whether we talk about the transmitting and receiving antennas. When the wave is being propagated out of these mediums, the attenuation factor is introduced in the atmosphere through which it is being propagated. And as we go on increasing the distance of the transmitting and receiving antennas, as well as we going on increasing the frequency, the attenuation factor is also altered according to that. So the power density of the transmitting antenna, when the attenuation factor alpha is also introduced in it, then the power density is given by transmitted power upon the area of sphere into the gain factor that is was being introduced into alpha. Now alpha is the second factor which is now introduced because of the attenuation factor that was being introduced in the antenna. Now this whole concept is all about the transmission of the signals through a transmitting antenna. Signal transmission through a transmitting antenna. Now we move on towards the receiving antennas. Now we move on towards the receiver section. Now when the wave is being transmitted from the transmitter towards the receiver, now the amount of wave that is being propagated from the transmitter towards the receiver depends upon the effective aperture of this receiving antenna. Amount of effective aperture or the effective aperture of the antenna, highest the effective aperture, more the effective aperture, more is the radiations absorbed by the receiver, or they are taken by the receiver. So ultimately the power density of the transmitting antenna that was being given by Pt upon 4 pi r square into the gain factor into the attenuation factor alpha. Now the gain factor which is introduced by the receiving antenna, the gain factor which is introduced by the receiving antenna is given by 4 pi a upon lambda square. Now this is according to the antenna theory. This relation comes from the antenna theory, which states that A is the effective aperture of receiver and lambda is the wavelength, of the transmitting signal. Now if we take out the value of A out of here, A will come out to be G into lambda square upon 4 pi. So if we take about the total power received, now out of this if we take out the total power received by the receiving antenna, then that is given by Pt into Gt into Gr into alpha into lambda square by 4 pi d square. Now that is the actual received power which is being received by this receiver antenna by using the antenna theory equation. If you put on the value of this equation A into this equation, we will get out the total power received by the receiving antenna. Now that is the actual equation of the free space equation, or the free space equation of the receiving and the transmitting antenna, which is being used for the transmission of the signals. Thank you very much, class.